In my previous video, I talked about how tokenizing works and then wrote my own tokenizer for a made-up Discord script programming language. Now, with everything broken up into tokens, I can begin working on the next step of the process, which is the parser. So, what is a parser? Well, in a TLDR, the parser converts our big long string of tokens into a more structured format based upon our language's specifications, as well as performs compile time validity checks. Now, yes, I know this language is a translated language and not a compiled one, but due to the nature of how we load, tokenize, parse, and execute this program all at once instead of, say, line by line, we do have a compile time-like syntax check while parsing the input. I guess you could technically make the argument that this is a compiled language, but the lines between compiled and translated can get very blurry at some points, so I will just stick to saying that this is interpreted language since we don't output to any other language file format. Anyways, so how does the parse make these checks and get our script prepared to be executed? Well, the first part is to understand what the end goal is for this language. Because we are using Java, the end goal is to convert the tokens into objects, where each object represents a different block of code. Essentially, we will have a while block loop class, a function block loop class, an if statement block class, etc., for each sort of major syntax structure we have. Typically, one class for each BNF key you define, but I don't have a BNF defined, so for me it'll be a lot of making this up as I go. Really, all I'm doing though is simply utilizing polymorphism to do a large amount of the work for me. I can simply give each class a parse and execute method that will then handle these functions for me and allow me to break down this process into more manageable chunks, as well as storing these objects much more easily. Okay, so that makes sense. But how do we get these objects from our stream of tokens we created? Well, if I had a BNF diagram, it would be probably much easier for me to show you guys, but essentially each block of code has a more or less defined structure to it. So if we read in a stream of tokens, we can use a state machine-like approach to parse out our tokens and determine if they are syntactically correct. And if you don't know what state machine is, just think of it as a fancy way of knowing what token or tokens come next depending upon the tokens you have previously read in. For example, say we are parsing in an if statement. We know we need to parse in an if statement when we hit an if token. After that, it follows a very defined structure. An if token, followed by a left parenthesis token, followed by some condition, followed by a right parenthesis token, followed by a left curly brace token, followed by the code body, ending with a right curly brace token. This example also very nicely shows how nested parsing works because both the condition and internal code body are very ambiguous, but we can keep breaking them down in the same style we just did our if statement until we've parsed each and every token. The validity check is also done at this point because of this rigid structure. We know if we have an if token but no left parenthesis following it, we have a syntax error and thus an invalid program. And honestly, just like the tokenizer, that's all there really is to it. It's honestly not a complex idea. The complexity for this really just comes down to the elements that have a lot of variation and less structure, mainly the condition and math-like expressions. So anyways, let's get into the coding. So kind of like last time though, there's not a whole lot to this really. The tokenizing and parsing structure are very simplistic in idea, but it just comes down to it's a lot of programming over and over again of, in this case, making each of the classes and then slowly parsing out each of the individual tokens to make sure that the token stream you get in is actually what is expected and it is valid code. I ended up making this kind of big function here, which essentially just takes in the token stream and decides upon which token or which method or object is actually meant to be parsed here based upon the current token. This is mainly used for like if statements, for loops, functions, basically anywhere you just have a big block of code that needs to be parsed out, kind of make this more autonomous and just make it much more condensed in that nature. The only place where the parsing became a little more complex was with conditions and expressions, as I mentioned before. I've been changing up a lot since this video. Actually, I'm recording this. I've already started making the executor. So since this video that you're seeing in front of you has kind of been done, I've been changing the parser up to match the executor, going back and forth. And essentially what I've kind of decided upon now is that the condition will use the expressions to kind of build itself up, it's kind of go back and forth. But at the end of the day, the expressions are the more kind of complex bit, as they got to handle all the math expressions, handling passing to functions. There's a lot of ambiguity with it and a lot less structure. Well, there's still structure, but there's a lot more cases with the structure than the rest of them. So basically, I'm just starting small with the expressions, and I'm just slowly building it up over time, which honestly, when you develop a language, you will likely do is you will likely not start with this entire code example to start with. You usually start with very base code examples, and you'll slowly build up and add functions, add if statements, else statements, all that. So yes, there's a lot of kind of initial work to be done here. There's not a whole lot of kind of complex things to do necessarily, but that's mainly because I've chosen to kind of go all in right away and not build up anything over time. So if you were to do this yourself and make your own programming language, you probably get a different experience than I did. But at any rate, this is what I've done, and this is kind of why it's like this. There's a lot of work, but there's not a whole much to say about it. Today, though, we have now parsed out our program. We have checked for validity of the code, and we have parsed it into the objects and is ready to be executed, which will be the next video. So hope you guys enjoyed. I am currently still working the executor. If you want, feel free to follow me on my Twitch, twitch.tv/turkeydev. That's where I'm currently working on it in between other projects. So if you're interested in seeing me working on it, check me out there. Slowly getting it there. As I said, I'm going back and forth between the parser and the executor to get them kind of matching better and working better together to do all this work, because again, they're feeding right into each other. So obviously if I make the parser a little better, I can make the executor better as well. So hopefully you guys enjoyed again. I'll see you guys all next time for the executor. Thank you guys for watching. See you guys next time. Peace out.